Hello friends, up to last session we have seen basic concept of partial derivatives and higher order partial derivatives and some typical examples of partial derivatives. Now today we are going to start with a chain rule and total derivative. Now what is a chain rule and what is the total derivative? Simple chain rule for one variable function you have learned that y is some function of u and u is some function of x. Then you are writing it as dy by dx is equal to dy by du into du by dx, correct? That is a chain rule for simple one variable. Now we are concerned with a multivariable function. Suppose first we are starting with a basic simple chain rule. Suppose z is a function of u and u is a function of x and y. Okay. Then in that case, if you are going to put the value of u in z, then that will give you z is a function of x and y, correct? That means if you are finding the derivative, then you can find the partial derivative because z is a multivariable function. So del z by del x is given as dz by du into del u by del x, and del z by del y is dz by du into del u by del y. See why we have written in this form. Z is a function of u and u is a function of x and y. That means z is a one variable function and that's why you have taken a total derivative dz by du. But u is a multivariable function. So whenever you are going from u to x, at that time you have to treat y as a constant and that's why it is del u by del x. Same manner if you are going on to y, then at that time you have to treat x as a constant. Okay, so you can either differentiate z with respect to x or you can differentiate with respect to y. Same manner, suppose you have three variable function. So suppose you have a multivariable function, u is a function of x and y, and we are going with a total derivative. That means u is a function of x and y, where x is a function of t and y is a function of d. Then in that case you can find the total derivative. Why? Because if you are going to put the value of x and y in u, then u is going to be a function of t at last. That means u is a function of one variable. That's why you can find out the total derivative. And derivative of u with respect to t, that is du by dt, is defined as del u by del x into dx by dt plus del u by del y into dy by dt. Why? See, u is a function of x and y, x is a function of t, y is a function of t. That means if you are going from u to x, then it is a partial derivative. But x to t is a one variable function, that's why it is a total derivative dx by dt. Same manner u to y, then it is a partial derivative because it is a multivariable function and that will be a del u by del y. But y to t is a one variable function, that's why it is dy by dt. And whatever the paths you have which are going on to t, you have to add them all. Okay, so here we have two different paths, so we are going to add them both. So first you will have del u by del x into dx by dt plus del u by del y into dy by dt. Instead of two variables, suppose u is a function of three variable x, y and z, then you have to again applying same process and that will give you du by dt. That will be del u by del x into dx by dt plus del u by del y into dy by dt plus del u by del z into dz by dt. Okay. Now that is a total derivative. Now we are going with a chain rule. Now in a chain rule, suppose u is a function of x and y and x is a function of rs, y is another function of rs. That means now you have a multivariable function x and y. So if you are going to put x and y in u, then you will have u is a function of r and s at last, correct? So again it is a multivariable function if you are going to substitute the values of x and y. That means now you cannot find the total derivative. So either you have to differentiate u with respect to r or you have to differentiate u with respect to s. Okay, so partial derivative of u with respect to r, that is del u upon del r, is given by del u by del x into del x by del r plus del u by del y into del y by del r. Because see, you have two paths. First one is from u to x, x to r. Second one is from u to y, y to r. Okay, and you have to add them both. Same manner, if you are differentiating with respect to s, then again there are two paths. First one is del u by del s, del u by del x into del x by del s plus del u by del y into del y by del s. Okay, the same manner you can apply it for 3 variable or 2 variable or any number of variables. Okay, now if we are starting with example, if w is a function of x, y plus z and x is equal to cos t, y is equal to sin t and z is equal to t, then find dw by dt. See here, w is a function of 3 variable x, y and z, and x, y and z are functions of t. So if you are going to apply the simple total derivative formula, then dw by dt is given by del w by del x into dx by dt plus del w by del y into dy by dt plus del w by del z into dz by dt. Correct? Now putting the values of del w by del x, that is nothing but y, and dx by dt, that has a value minus sin t. Same manner, del w by del y, derivative of w with respect to y, that will be x, and dy by dt, derivative of y with respect to t, that is sin as a derivative cos t, and del w by del z, that is derivative of w with respect to z is 1, and dz by dt and derivative of z with respect to t, that is also 1. Now we have to put all values in the form of parameter t. That's why putting the value of y and x, that will give you minus sin square t plus cos square t plus 1. But cos square t minus sin square t has a value cos 2t. So you will have cos 2t plus 1. And also we can replace 1 plus cos 2 theta by 2 cos square theta, that is 2 cos square t, or you can put it as it is. Okay, so the final answer of dw by dt, that will be a 2 cos square t. One another example we are going to take is if z is equal to xy square plus x square y, where x is equal to at square and y is equal to 2at, then find dz by dt. Here see, z is a function of 2 variable x and y, and x is a function of t, y is a function of t, correct? So your chain rule will be dz upon dt is equal to del w by del x into dx by dt plus del z by del y into dy by dt. So del z by del x has a value y square plus 2xy and dx by dt has a value 2at. Same manner, del z by del y has a value 2xy plus x square and del dy by dt has a value 2a. Now putting the values of x and y, x is equal to at square and y is equal to 2at, and simplifying all the terms, that will give you dz by dt is equal to 16a cube t cube plus 10a cube t raised to 4. Okay, so this is the final answer of dz by dt. Now we are going with another example. If z is a function tan inverse of x by y and x is equal to u cos v, y is equal to u sin v. That means at last z is a function of 2 variable u and v, correct? So if you are going to find the derivative, then either z can be differentiated with respect to u or it can be differentiated with respect to v at a point 1.3 comma pi by 6. So what we are going to do is, we are first finding del z by del u. Now first you have to find out derivative and then you have to substitute the points. So del z by del u is equal to del z by del x into del x by del u and plus del z by del y into del y by del u. Because see, z is a function of x and y, x is a function of uv, y is another function of uv. That means if you are going to apply the chain rule, then you have to take a partial derivatives. Now del z by del x, derivative of z with respect to x. So tan inverse has a derivative 1 upon 1 plus x square into derivative of x by y with respect to x, that is 1 upon y, and del x by del u, that is cos v, plus derivative of z with respect to y, that is tan inverse has a derivative 1 upon 1 plus x square, and x by y has a derivative minus x upon y square with respect to y. Same manner, del y by del u, that is sin v. Now taking LCM and simplifying, that will give you y cos v upon x square plus y square minus x sin v upon x square plus y square. And if we are going to put the values of x and y, that will give you u sin v cos v minus u sin v cos v divided by x square plus y square, or you can write down u square, and that has a value 0, correct? Same manner, if we are going to find del z by del v, then it is del z by del x into del x by del v plus del z by del y into del y by del v. Now del z by del x is again 1 upon 1 plus x square upon y square into 1 upon y, and derivative of x with respect to v is minus u sin v. And del z by del y is again same 1 upon 1 plus x square upon y square into minus x upon y square. And del v by del y, del y by del v has a value u cos v, correct? And simplifying by taking LCM, that will give you y into u cos x minus x into u sin v divided by x square plus y square. Putting the values as u cos v has a value y, u sin v has a value x, so that will give y square minus x square divided by y square minus x square. So minus common out and cancel out y square minus y square, that will give you the value minus 1. Now here, in both of the case, del z by del u or del z by del v, you get a constant answer. So if you are going to put the value of x and y as a 1.3 and pi by 6, then also the answers are going to be same, okay? Now, we are going with an example. See, now here we are starting with if u is a function of x minus y, y minus z, z minus x, then prove that del u by del x plus del u by del y plus del u by del z is equal to 0. See, here you have not given the function directly in the form of x, y, z, but you have given it is the function of x minus y, y minus z, z minus x, and you have to differentiate it with respect to x, y and z. So here you have to apply the chain rule, and for that we are going to assume that x minus y is equal to L, y minus z is equal to m, and z minus x is equal to n. So u is a function of L, m and n, where L is a function of x, y, z, m is a function of x, y, z, and n is also a function of x, y, z. So if you are going to apply the chain rule, then del u by del x, that will be written in the form of del u by del L into del L by del x plus del u by del m into del m by del x plus del u by del n into del n by del x. And your function u is of the form f of L comma m comma n. Okay. Now you don't know what is the exact value of function u. Correct? Function is not given. It is in the form of f. So del u by del L, del u by del m and del u by del n are remaining as it is. And you have to put the value of del L by del x, del m by del x and del n by del x. So del L by del x has a value 1, del m by del x has a value 0 and del n by del x has a value minus 1. So putting that value and simplifying, that will give del u by del x is equal to del u upon del L minus del u upon del n. Okay. Now this is your equation number 1. Same manner, if you are finding del u by del y, then it is del u by del L into del L by del y plus del u by del m into del m by del y plus del u by del n into del n by del y. Again putting the value of del L by del y, del m by del y and del n by del y, that will give you the simplifying term minus del u by del L plus del u by del m. Okay. And same manner, del u by del z has a value minus del u by del m plus del u by del n. Now see, put all values in left hand side, or you can add 3 of all equation 1, 2 and 3, that will give you directly answer 0, which you have to prove out. So in such a case, first you have to assume something and then you have to make it in form of chain rule, and then you have to find out what are the original derivation or what are the derivatives they have asked. Okay. Now we are going on to the implicit function. Suppose f of x comma y is equal to c is any equation we have given or any function we have given, and Here either x is a function of y or y is a function of x and c is a constant. Then in such a case, this equation is called an implicit function. That means here you cannot write down y as a function of x or x as a function of y. But we are going to consider that either of variable is a function of another one. And you have to find the derivative of this type of function. Then in that case, we are going to apply the simple total differential. Suppose example we have written is x cube plus y cube is equal to 3xy. Here you cannot make x subject or y subject. That means this function is an implicit function. Or you can write down x raised to y plus y raised to x is equal to c. Again, that function is also an implicit function. So if you are finding the derivative of implicit function, then if f of x comma y is equal to constant is an implicit function and we are considering that y is a function of x with a first order partial derivative is not equal to 0, then in that case dy by dx is equal to minus del f by del x divided by del f by del y, that is equal to minus fx upon fy. Okay, and the proof is very simple. We are going to use the chain rule. You are considering that f of x y, that means is equal to constant, that means f is a function of x and y, and we have assumed that y is a function of x. Also, derivative of y with respect to x is non-zero. That means del f by del y is not equal to 0. In that case, if you are going to find the chain, applying the chain rule, then df by dx will be 0 because you are differentiating with respect to x. F is a function of one variable x at last. So, del f by del x into dx by dx plus del f by del y into dy by dx is equal to 0. Dx by dx has a value 1 and making dy by dx subject, that will give you minus del f by del x divided by del f by del y. That means minus fx upon fy. Here you have to check with provided that the denominator is non-zero. Now we are going on to the example. If x cube plus y cube is equal to 3axy, then find dy by dx. Now see this, here you cannot write down y in a form of x or x in a form of y. Correct? That means this is an implicit function. First of all, you have to write down your equation in a form of equal to 0. That means you have x cube plus y cube minus 3axy is equal to 0. And we are going to take left hand side is equal to function f. So let f of x comma y is equal to x cube plus y cube minus 3axy. Now first we are differentiating f with respect to x, that is del f by del x is equal to 3x square minus 3axy, and same manner del f by del y, that will be a 3y square minus 3ax. Correct? And putting both values in your derivative dy by dx, that is dy by dx is equal to minus del f by del x divided by del f by del y, and that is minus of 3x square minus 3ay divided by 3y square minus 3ax. 3 common out and cancel, and multiplying minus inside, that will give you dy by dx is equal to ay minus x square divided by y square minus ax. Same manner, second example we have taken is cos x raised to y is equal to sin y raised to x, and find dy by dx. Here again check out, you cannot make x or y subject, that means you cannot write down x in a form of y or y in a form of x. So here you have cos x raised to y is equal to sin y raised to x. Taking log both sides. For simplicity of differentiation, we are taking log, otherwise you can differentiate directly. So simplicity, we are taking log, that will give y of log cos x is equal to x into log sin y. Correct? Now, writing equation in a form of equal to 0 and assuming that f of x comma y is equal to y log cos x minus x log sin y. Differentiate f with respect to x. So y as it is log cos x as a derivative 1 upon cos into minus sin, and then minus x log sin y as it is derivative of x is 1. So simplifying the terms, you will have minus y 10x minus log sin y. Same manner, if you are differentiating f with respect to y, then derivative of y is 1 log cos x as it is minus x as it is log sin has a derivative 1 upon sin into cos. Simplifying the terms, that will give you log cos x minus x cot y. And if you are going to put both values in dy by dx, then that will be minus del f by del x divided by del f by del y. And simplifying, that will give you the term y tan x plus log sin y divided by log cos x minus x cot y. So these are the topics we have covered today. Now, if you have any query or any doubt regarding these topics, then please feel free to contact me. Thank you.